Okay, so this is just describe a short bit of code which I've written in Fortran for calculating the Weibull parameters. So in a Weibull distribution, there's two parameters which are used to specify it, and that affects the way it looks. So here we've got some wind frequency data, which is the one in black, and then the Weibull parameter. Let's go to the Weibull parameter sits on top of that, and so the K and C values are the ones that specify the fit. So if we just put two default values, 2 and 6, say, then you can see that these curves here don't match it very well. The orange and blue ones, just ignore them for the time being because they're like the cumulative equivalent of the Weibull distribution. We're just looking at the PDF version of the Weibull. So yeah, so basically what you want to do is be able to estimate these values so that you can get the best fit for the data. And you also, it's better if you put in a location, a starting location as well. So that's a 3-point Weibull distribution where you put in a lock location value. So I've set it as 1 here, and you do get a better curve fit if you use that to specify that value as well. So there's some Fortran code which I've written, and it's really simple. So basically you specify your speed values and you specify your wind frequency values, and then you just normalize them by the wind direction, the probability for that particular wind direction, and also the bin size. And then what this does is basically this is the equation for the Weibull distribution. It calculates the values in a Weibull distribution and then compares them with the wind data and takes the absolute value and then sums it up over the 6 points in this case, and then saves that value. And so basically you're just varying values of K and C to find the minimum difference with the wind data. And it works really quick and it gives you 2 decimal places of accuracy. So if I just compile and run this code now, that's ran. That just tells you, confirms what wind data is used. Then it tells me 2.92 and 4.94. And that is for a fixed value of 1, I think, the location. So then if you go back to this distribution and then put in 2.92 and 4.94, then you get a really nice curve fit. And that is using my equation for the Weibull, which I've put in manually, and also put in the Excel version of the Weibull, and they're both identical. And so you can see them on top of each other. So yeah, that's the Weibull distribution with the estimated values for the parameters.